everybody's good, everybody's safe, and we'll get started in a moment. I'm going to stall for a few moments, just like I usually do, to kind of give everyone a chance to log in and check everything out. And if you're here, if you're watching, please leave a comment so I can see who's here. It's just good to know who I'm talking to. All right, so having said all that, yesterday I put an assignment on Google Classroom to kind of practice what we were doing yesterday, and that was identifying reaction types, predicting products, and then balancing. You got to do them in that order. So identify, predict, and then balance. So I put a worksheet on the Google Classroom, and this is what it looks like here. So we're going to do a couple here. Now, I did get a question or two about number one. Number one is just an example that's already given to you. Okay, everything you need is right there. Let's see if I can zoom in a little bit. All right, hopefully that should give me enough room to do everything while you guys can still see it. So what's up, Connor? It's good to see you back. All right, next, let's do, hey, Kaylin. Let's do number two, okay? This one shouldn't be all that hard to identify. If you go by the notes that we talked about yesterday, just go back and watch that video, okay? That will help you figure out what kind of reaction we're dealing with. And once you know what kind of reaction you're dealing with, then you can follow the pattern to predict the product. So keep in mind, there's less information given to you more and more as we go forward. So this reaction is actually going to be a combo. So you would write combo there on that line, okay? Now, the reason why I know it's a combo is because it's a metal and a diatomic. That's just the pattern. That's just what we said yesterday. Now, since it's a combo, we're going to have to do the crisscross. So you have to go to the periodic table. You got to find the charge for aluminum and the charge for chlorine. Well, aluminum is a +3. Chlorine is a -1. So what you do is crisscross Al +3. Chlorine's a -1. So that should be the answer there. The very last thing you got to do is balance. All right. Now, with all the tips and everything that we've talked about, aluminum is by himself, so we're going to do that last. Let's do chlorine first. I'm going to get them both to 6 since I have a 2 and a 3. All right. So I'm going to put a 3 here and a 2 there. That means now I have 2 aluminums. Finish it off that way. All right. I hope this is making sense. This is not incredibly difficult, and it's almost like once you get it, you're going to kind of, almost get annoyed that it was tricky at one point because you're just following patterns. All right, so for number 3, you got iron 2 chloride and potassium hydroxide. That looks like to me a double because it's 2 ionic compounds. So let's call it a double. Now, yesterday we talked about how doubles are just going to have the metals switch places, okay? So iron used to be with chlorine, and potassium used to be with hydroxide. So they're going to switch. Iron 2 is going to be with hydroxide. So you got to do the crisscross here. Okay. That's for the first product. The other product is the crisscross between potassium and chlorine. It's a +1 and a -1, so you only need one of each. And then you're going to go back and balance everything. All right. It looks like we have 2 chlorines here, so I'm going to put a 2 here. Now, when that happens, now I have 2 potassiums. So I'm going to go over here and fix that potassium. We got to kind of squeeze it in. And that means now I have 2 hydroxides, which I happen to have over here already. And then 1 iron and 1 iron, you're good. Okay, is everybody following along? Hopefully this makes sense. Let's see. I got 3 people. Okay. So how's the image? Is the image okay? I'm getting a warning here that the image might not be all that great. So how's it look, you guys? I'm trying to figure this out as I go. Now the warning went away. Okay, anyway, we'll see what happens. I guess it was just a glitch in the Wi-Fi. Okay, let's do number 4. Number 4 looks like a combustion because of the O2. Okay, very good. Thank you, Connor. So the O2 as a reactant tells you it's a combustion right away. So just call it a combustion. Okay, thank you, Kaylin. Now, because of that, we have to look at what is being reacted with the oxygen. This is what we would call a hydrocarbon. Hydrocarbons, you don't have to guess or figure out what the product is going to be. It's going to be CO2 and H2O each and every time. That's it. It's more of a rule than trying to figure something out. There's no guesswork or anything involved. You don't have to go, what's it going to be? How can I figure it out? It's a rule, all right? Now, last thing you got to do is balance. I'm going to do oxygen's last here because he's by himself. So I got 2 carbons. I'm going to put a carbon, put a second one there. So now I got 2 of those. And I have 4 hydrogens, so I'll put a 2 here. This is going to work out real nicely. For your oxygens, I have 4 oxygens here plus another 2, so that's 6. I need this to be 6, so put a 3. All right, how are you guys' confidence level on balancing, since that was the first thing we talked about? All right, so let me know in the comments what you think about balancing, just balancing, and then I'll ask a follow-up question from there. In the meantime, I'm going to go on to number 5. Now, number 5, 2 ionic compounds. This looks like a double. Okay. Aluminum used to be with sulfate, and lead 2 used to be with nitrate. So we're just going to switch places. Lead 2 will be with sulfate, do the crisscross, PbSO4. And then aluminum is now with nitrate, so Al, crisscross. Okay? So it's not terribly difficult. Okay. All right, so I got one feedback saying that balancing is good, having trouble predicting. Okay, Connor. It's just take practice, to be honest with you. It's just going to take more and more. So we'll do this whole worksheet together, and you have to go back and watch that video from yesterday with the all the rules of the patterns for the predicting products. If you can balance, once you figure out what kind of reaction it is, coming up with the products is just the next step. All right, so anyway, number 5, we need the balance. So I'm going to look at nitrates first. Okay, thank you, Kaylin. So the nitrates I'm going to look at first because you see how I have 2 here, but then I have 3 over here? It makes sense to deal with them first, only because if I start dealing with other stuff, I might have to go back and adjust all the work I had already done when I finally get to nitrates. So in this particular case, let's do that one first. So let's bring them both up to 6. I'm going to put a 3 there and a 2 there. So that means now I have 2 aluminums. It already matches, right? And I have 3 sulfates, which I need to put a 3 here. And when I fix my sulfates, I also fix my leads. So all in one shot, I get everything done, okay? Connor and Kaylin, you guys are my all-stars. You guys are the ones who keep coming back every day. If there's anyone else watching, you got to say something. Looks like I got 3 people in the room, in the chat, but only 2 of you guys are saying anything. Anyway, let's look at excuse me. Let's look at number 6. Okay, number 6 is the next one, and this one's not terribly difficult either. Okay, I have a metal and a ionic compound. So what we're going to do here is look back at our patterns that we talked about yesterday and realize that this is a single. Okay, metals are going to switch. That's going to happen in all singles and doubles. So barium used to be by himself. Magnesium used to be with iodine. So now magnesium is going to be alone. And then barium's going to take his place. And you got to do the crisscross with barium and iodine. All right, now let's take a look here. See this 2 here with the iodine? This 2 is there because of the crisscross with magnesium. This 2 here is there for a different reason. Now it's with the crisscross of barium. So that 2 has nothing to do with this 2. It's just a coincidence, okay? It just so happens that both magnesium and barium have the same +2 charge, and as a result, you get these compounds and their formulas. This is already balanced because of that. All right, next, let's look at number 7. Now, this one is tricky, okay? I'll give you this one. I'm going to do the guess and check method with this. Now, that should be a hint, okay? There's only one reactant. When you see heat, you should automatically and I didn't mention this yesterday, but when you have one reactant and heat or just one reactant, it's always going to be a decomposition. All right, heat is going to be a clue. It's not always going to be there, but if you see heat, you should be thinking decomposition. Regardless, there's only one chemical involved here anyway, so that's going to be, by default, a decomp. Okay, so now, for this one, for the more difficult decompositions like what we got here, we're going to use the guess and check method. And how you come up with your products are, you got to think of things that are possible, whether it's from the crisscross or compounds that you've heard of or what have you. So here's what I'm going to do. I'm going to make calcium oxide, because calcium hydroxide is going to break down into different pieces. But I'm also going to try making water. All right, so let's take a look. So basically, you got to realize you got calcium, you got oxygens, and you got hydrogens. What can you make with those three things? Well, you know that you can make calcium oxide, crisscross, and it's neutral. Water is also a very common thing. So let's take a look, and how you check is to see if it can be balanced. If it can't be balanced, it is not the right set of products. All right, I'll say that again. If you can't balance it, the products are wrong. Go back, get different products, and try that. So let's check to see if we can balance this. One calcium, one calcium. I have two oxygens, and I have 1 and 2 oxygens on the right. I also have 2 hydrogens. I have 2 hydrogens. There you go. It's already balanced. So this one is good, okay? It doesn't always work out that way. That will come with practice, okay? Don't sweat the decomps just yet. Try them, but don't get all, upset if you can't get it right. Hang on, guys. Sorry, I thought I heard a noise. The house we bought was very affordable, and it's not in the greatest of neighborhoods. So, having said that, it's, got to keep your eyes open. It's not like a war zone over here, but it's a neighborhood where it's not Burlington Township, okay? Let's put it that way. Anyway, let's do number 8, okay? We're going to do this whole worksheet. We're about halfway through at this point. So number 8, I have 2 ionic compounds. Yesterday I mentioned if you see H's out front, that's an acid. We're going to treat these as ionic compounds. So 2 ionics, that means it's a double right away. No thinking. Now, the metals are going to switch, and hydrogen is going to act like a metal. Potassium is the other metal. So I'm going to take H and OH and do the compound there. It's really just water, isn't it? HOH or H2O. I'm going to write it as HOH because that might help me balance it later. Then I got to do the crisscross between potassium and sulfate. So you get K2SO4. Okay? Now to balance it, it looks like I got 2 H's. I only got 1 H over here, so I'm going to put a 2 there. Now I have 2 hydroxides. Let's put a 2 here. And that gives me 2 potassiums. It just so happened I already have 2 over here. And then sulfate's already balanced out. 1 sulfate and 1 sulfate. All right? If you notice, I'm kind of moving a little faster here with the balancing, because we've done dozens of them together, and you probably have done a bunch yourself, hopefully. And I really don't want to harp on balancing if, like you guys say in the chat, that you're okay with the balancing. What we need to worry about next, if we're both good with balancing, all 2 of you that are participating in this, Connor and Kaylin, are you guys okay with deciding what kind of reaction? All right, I'm trying to figure out if you guys are good with identifying the reaction type. If you're good there, if you're not good there, let me know either way, okay? In the chat there, tell me how you feel about identifying reaction types, whether you have the products or not, because that's going to happen all the time. All right, so I'm looking for some feedback there. In the meantime, I'm going to move on and do number 9. Now, number 9 has a special note here. It says that zinc is a +2 ion. You're going to see zinc more in the future, and you're going to want to get that in your brain, that zinc is a +2 ion, okay? So put that on your periodic table, your notes. whatever. I mean, we all know that at this point, this is kind of open notes and what have you. So somewhere, know that zinc is a +2. And Connor, like I said, this will just come with practice. You're going to be okay, I promise. Especially if you keep doing this. You're one of the few people who are, so you'll be fine. Kaylin, just waiting to hear how you feel about identifying reactions. All right, so for number 9, we got a metal and an ionic compound. Okay, Kaylin, same thing. Just like what I said to Connor, you're going to be all right. We'll get this. So metal and ionic compound, that's definitely a single. Okay. Let's see here. Then, I'm sorry, I've got stuck in my own thoughts for a second. Since zinc is a +2, it says so right here, we got to do the crisscross with chlorine. And you're going to get ZnCl2. And then H will be by himself. Here's the tricky part. H is a diatomic, so you need 2 of them. If you leave that 2 out right here, you're going to have a very tough time balancing this one in particular. You got to have that 2 because it's a diatomic. Remember the 7? Anyway, real easy to balance because of that. You just put a 2 there. Fix your hydrogens and your chlorines. Okay. Now, what I want to do, there's going to be a weird, awkward delay for me, but I'm going to give you a few moments. I want you to, in the chat section there, tell me what kind of reaction number 10 is. Now, let's do 10 and 11. You're not predicting products right now. I'll do that with you. But just tell me what kind of reaction you think they are. Number 10 and 11. So I'm looking for 2 answers from both of you guys, Kaylin and Connor. All right? So I'm going to kind of sit here. I'm going to awkwardly drink my water like I do in class. And hope that there's not a burglar in my house at the moment. That'll make for an interesting video. All right, so 10 and 11. Just tell me what kind they are. Excuse me. Hopefully you guys tried this before this video today, and you have some answers. And it's just the delay that's making me look awkward right now. Let me text my wife real quick while we're waiting on Kaylin, okay? Connor, I see your answer. I don't want to just give the answer away just yet until we get word from Kaylin. I mean, currently there's 3 people in here. So, all right, Kaylin, give an answer. Okay, let's see. Let me finish this text and we'll... Okay. Sorry. Anyway, all right, so both you guys agree that number 10 is a combo. And then, Connor, you say 11 is a single, and... Jeez. And Kaylin, you say 11 is a double. So let's take a look, all right? And if the third person, if you're watching, you can participate, whoever you are. Just say hi and, let me know what's going on. Number 10 is definitely a combo because you have a metal and a diatomic. That's like number 2 that we did earlier, right? A metal and a diatomic. So number 10 is definitely a combo, okay? So now potassium and bromine are going to get together. So you got to do the crisscross. It's a +1 and a -1. So 1 of each, and then you balance like so. All right? That was an easier one, okay? Now let's look at number 11. I'm going to say number 11 is a single, and here's why. You have a metal plus an ionic compound. For it to be a double, it would have been 2 ionic compounds. All right. Does that make sense? Kaylin, let me know that you got that. So we have a metal ionic compound that just follows the pattern. Now, excuse me. So magnesium used to be by himself. Iron used to be with sulfate. Now iron is going to be alone. They switch places. Magnesium is going to take the place of iron, and you do the crisscross here. Magnesium is a +2, sulfate's a -2, and there you go. All right? Okay, very good. Thank you, Kaylin, for the feedback. You guys are killing it. Thank you so much. Let's finish off this worksheet, okay? And then we'll talk for a few more minutes about the schedule and all that. Number 12. We have sodium hydroxide and hydrogen chloride. This looks like a double to me, just for the same reason that we were talking about number 11, 2 ionic compounds. Now, sodium used to be with hydroxide. Now it's going to be with chlorine, so sodium chloride. Hydrogen used to be with chlorine. Now it's going to be with hydroxide. Do the crisscross, and basically you get HOH, which is water. So when you mix these two things together, it looks like you get salt and water. You're going to get a mixture of salt water when you put those two together. And it comes out already balanced because everything is a +1 or a -1. And it's just straightforward there. Okay. Next one, number 13. This looks like a combustion because of the O2. Whenever you have O2, it's definitely a combustion. I got a hydrocarbon just like the one that we did earlier. So this is going to be the same two products, CO2 and H2O. Now, every so often somebody will ask me, does it matter which one you write first? No. You could write H2O plus CO2. It doesn't matter at all. It's the balancing that's going to come into play later. This one's going to be a little tricky, okay? Let's say, actually, no, it's not that bad. Let's save oxygen to the last thing that we do. I got 5 carbons, so let's put a 5 there. And I have 12 hydrogens, so let's put a 6 here. Now let's add up my oxygens. I got 10 plus 6. That's 8. 10 plus 6 is 16. So I need an 8 there. All right? I hope that isn't too bad. Number 14, we have 1 reactant. So that should be the dead giveaway right away. Okay? I got decomposition. And there's something that I say every year. And the only thing that one thing can do is break down. So when you have only one thing, the only thing that this can do is to break down into its pieces. The only thing that one thing can do is break down. So this one's a weird one, okay? This is going to be a guess and check type of deal. We have to figure out what products might be possible. Now, I'm going to try. I don't know if this is the right answer or not. I'm going to try CO2 and H2O. Okay? Now, I know that I have hydrogens, carbons, and oxygens. So I made a couple of products that have carbons and oxygens and hydrogens and oxygens. And these are 2 very common compounds that you definitely have heard of before we even met. So that's that. Let's see if we can balance it. 2 hydrogens, 2 hydrogens. Good. 1 carbon, 1 carbon. 3 oxygens and 3 oxygens. It's already balanced as is. So this is a good set of products right here. All right, number 15. We're almost there. This looks to me like it could have 2 answers in this one. This could be a combo because it's a metal and a diatomic, but you can also call this a combustion because of the O2. But either way, you're going to get the same product. You got to do the crisscross here between calcium and oxygen, and you're going to get CaO. And then you got to balance, put the 2 there to fix the oxygens, and then put the 2 there to fix the calcium. Okay, last one. Excuse me. This one looks like a single. I know it's a single because I have a metal plus an ionic compound. All right, so it's called a single. All right. All right, now, lithium used to be alone. Copper used to be with nitrate. Now, copper is going to be the one that's by himself. Okay? That means lithium is going to take copper's place and be with nitrate. Well, crisscross time. Lithium is a +1. Nitrate's a -1. So you only need 1 of each. Okay? And then you got to go back and balance. This one's pretty easy to balance. 2 lithiums. So I put a 2 there. And that also fixes my nitrates. Boom. Done. All right, so here's the deal for the rest of the week. I wanted to do new stuff today, okay? But it just seemed to make more sense if I give you guys time to practice. So what I'm going to do is I'm going to find another worksheet, and I'll put that up on Google Classroom. And from there, what we're going to do is use that worksheet as practice for today and tomorrow, okay? So you're going to work on that worksheet, and then tomorrow is going to be, every Wednesday is going to be like a breather day, all right? Nothing new on Wednesdays, just kind of a catch-up day, but we will still be doing a live stream for Q&A. So I'm going to give you another worksheet. You try it, and we'll do exactly what we did today again tomorrow, okay? All right, Connor, you're feeling a little better about it. Very good. All right. Then Thursday will be new stuff. And I want you guys trying these worksheets on your own. I mean, I'm only making like 25 to 40-minute videos. Class should be 76 minutes. So this is pretty much what we would be doing in class anyway. I teach you some stuff, and I give you time to practice it. All right? So just without the homework attached to it. So I'm going to log off in a moment. And then I will go to the Google Classroom and try and find a worksheet for you to try after the fact. All right? And then we will go over all those answers tomorrow. Deal? Deal. All right. Thanks again, you guys, all two of you that stuck with me to the very end. And I want to give you guys, you two specifically, an extra credit opportunity. Now, we did this in another video. So what I want to do is in the Google Classroom, the announcement for this video, I want you to list your favorite food. This is corny, I get it, but this is real easy for me to keep track of who's been paying attention and this and that. So go to the Google Classroom, find the announcement for this video today, and list your favorite food. And we're going to confuse people, okay? And anyone who didn't do this at 9 o'clock when I've been doing it for the past couple days at 9 o'clock, then so be it. They missed out, all right? So go to Google Classroom, list your favorite food, and in a few minutes, check back for the assignment, and you can try that at your leisure. But be sure to have it taken care of before 9 o'clock tomorrow morning so I can go over it, all right? So I'm going to close out the comment section on that announcement probably in like 5 or 10 minutes or so. Connor, you already answered. Just waiting on Kaylin. Once Kaylin's in there, because I know she's still watching, and she was with me from the beginning. All right? Kaylin, once you're in there, I will close this out. Favorite food. All right, guys, thanks again. I will see you tomorrow at 9 a.m. Thanks.